Okay, so I want to spend one more day on section 8.9. 8.9 was factoring, where you have special cases like you have a perfect square quadratic trinomial. You square root the front, square root the back, and you apply it into your factored form answer. But the second half of it is solving equations, and let's just start by telling me what is the answer to this guy right here. What's the answer? Without even copying it down, just what's the answer? What number minus 5 is 7? Yeah, the answer is 12, right? Everybody knows that. Everybody should know that. So just, you could show your work and go plus 5, but even without that, you're just thinking, what number minus 5 equals 7? Well, the answer is going to be 12, right? X equals 12. So the answer to an equation is something that'll make it a true statement. So the answer is 12. I want to jump to this one right here. We have an equation that says x squared equals 9. So you don't even think about doing any math. Just what number could fit in there? 3, right? 3 squared equals 9. So x equals 3, but x could also equal, anybody? What other number could fit right in here in parentheses that if I square it, it gives me 9 besides 3? Negative 3 also, right? So when we have a equation, x squared equals a number, and you're actually going to get two answers, positive 3 and negative 3 in this case. But what really happens, ladies and gentlemen, is to get rid of something, you do the opposite, right? So when I do the opposite of a square, that's really going to be a square root. And when I do what I do to one side, I must do to the other, and I square root the 9. And we all know that the square root of 9 is what? 3, right? So the answer is still 3, but notice that we actually have two answers, a positive 3 and a negative 3. So this is a rule that we have to always apply from here on out. In Algebra 1 and Algebra 2 and Pre-Calc and any advanced math class, whenever you apply a square root in an equation, you're going to put your answer as x equals, you have to put a plus or minus right in front of your answer. So what's the square root of 9? It's 3. And we put a plus minus right in front of it. What does that mean? The plus minus just means that it could be positive 3 or it could be negative 3. But from here on out, I want you guys to apply or put a plus minus in front of your answer whenever you apply a square root in your equation that you're solving. Let's just do one more quick one. X squared equals 25. What's your answer going to be right there? X equals what? Plus or minus 5. So if you just put 5, unfortunately, if you just put 5, you're only giving me half of the answer. So you only get 50%, which is bad, right? You only get half credit. You have to put either plus minus 5, or you could spend some time and say x equals 5 and x equals negative 5. But why do that when you could just put a little plus or minus right in front of it? That's representing both a positive 5 and the negative 5. Does that make sense? So whenever you have an equation that you're solving and you're trying to get x by itself on one side, you apply a square root, and whenever you apply a square root, you have to put a plus or minus right in front of your answer. Anyways, let's look at this one right here. Right here, we don't have just x squared. We have x minus 2, which is a binomial, in parentheses, squared. Okay? So if I wanted to solve this guy, what would I have to do? First of all, you want to get x by itself. You don't want this square on the outside. You don't even want this 2, but let's get rid of the square first. How do I get rid of a square? You could distribute and get a quadratic trinomial, and that's perfectly fine. It's gonna be a longer process, because how could I get rid of something? I do the opposite. So what is the opposite of a square? A square root. All right, so let's all do that. If there's a square right there and you don't want it, you could just square root it. And the square root and the square will get rid of itself. It'll eliminate. But what you do to one side, you have to do to the other. So you do the square root of the 25 also. Now, what did I say? When you apply a square root in an equation, what should you put in front of your answer? A plus or minus, right? So we have a plus or minus right in front of the answer 5. And over here we have the equal sign. And what's left over on the left side if the square and the square root eliminate themselves? What's left over? X minus 2. So you guys see how the square root, I want to scratch it out. The square root and the square, they eliminate themselves, and all you have left is the x minus 2. So here's our new equation. X minus 2 equals plus or minus 5. So I still need to get x by itself. What do? Add 2. That'll cancel it. Add 2. Now, it says you're going to add 2 to a plus or minus 5. And that's kind of weird, a plus or minus 5, right? So what we're going to do is we're going to rewrite it. We're going to say x equals, and I'm actually going to write the positive 2 first, and then I'm going to put the plus or minus 5. So what does it mean, plus or minus? Technically means plus and minus, right? But we say plus or minus. So this means that it could be 2 plus 5, which gives us what? 7. And it also technically means 2 minus 5, which gets us what? Negative 3. So ladies and gentlemen, on this third example that we did, we actually get 2 answers. X equals 7 and negative 3. X equals 7 and negative 3. So technically, when you get your answers, what you're supposed to do is double check them. And I say double check them. Let me go back to the original equation. The original equation was parenthesis x minus 2 squared equals 25. The reason why I say double check them is because sometimes we end up with extraneous solutions. Again, you want to check your answers because you might end up with extraneous solutions. This is the first time I use the word extraneous, right? An extraneous solution just means an extra answer that doesn't work. So if you were to plug in 7 right in here, what's 7 take away 2? 7 take away 2? 5. And what's 5 squared? 25. So does 7 work? Yes, it does. How about negative 3? If we plug in a negative 3 right there, we're going to get negative 3 minus 2. What's negative 3 minus 2? It's negative 5. And if you go negative 5 squared, no, negative 5 times negative 5, positive 25. So they both work, right? So don't think that they're always going to work. There's some rare times that when you check your answers, one of them doesn't work and one of them does. Or sometimes you check your answers and none of them work and you would say no solution. But anyway, let's try another one. Copy this one down. We have x squared plus 10x plus 25 equals 0. Now, we know that the a value is 1, so we could think parenthesis, x, and then think what times what is 25, that if you add together is 10. Or you could do what we were doing in this section. You have a perfect square term here, a perfect square term there. You could square root them and then plug them into your answer format. The square root of x squared is x, the square root of 25 is 5. And we know that the middle term is a positive 10x. So that must mean that these guys are what? Positives, right? You can't put 1 plus 1 minus because that would make the middle term disappear, right? They either have to both be positives or both be negatives. So anyways, they're both positives. And again, we found out that they were both positives by thinking about the middle value sign. Okay, so I could also rewrite the x plus 5 times x plus 5. I could rewrite it as x plus 5 squared equals 0. Now, why would I do that? Because I could get rid of the square by doing what? By square rooting. And what I do to one side, I do to the other. Just don't forget to put a plus or minus right in front of your answer, but the square root of 0 is still 0, right? And a plus 0 or a minus 0 is not going to change anything. But so right here, in this case, the plus or minus doesn't produce 2 answers. But I do have an x plus 5 left over. So here's my equation. X plus 5 equals plus or minus 0. So what do I do now? Subtract 5, and I end up with, just for the sake of practicing, let's write it like this. X equals a negative 5 plus or minus 0. But the plus or minus 0 is not going to create 2 different situations. Negative 5 plus 0 is negative 5. Negative 5 minus 0 is still negative 5. So your answer is x equals negative 5 for that one. Okay. You could have also, if you wanted to just think about it differently, you could have taken this one and split them and said x plus 5 equals 0 and x plus 5 equals 0, and you get both the same answer, x equals negative 5. How about this guy? What do I do first? Square root? Say again? Add the 9 to both sides. That'd be great. Why? Because we'd end up with a 0, which means that we're probably going to be able to use zero product property. So we have x squared minus 6x plus 9 equals 0. And we could do the square root of the first one, square root of the last one, and plug it into our answer format. Or because the a value is 1, I could just jump right into an x and an x and think what times what is positive 9, that if I add together is negative 6. What is that? What times what is positive? 3 times 3? Okay. All right, how about if I were doing it the other way? I square root this guy, I square root that guy, I get an x, I get a 3. I get an x, I get a 3. What symbols belong in there? What signs belong in here? Minus and a minus. If you put a minus and a plus, the middle term will eliminate, right? That's only for perfect square binomials, the difference of two squares. But if you have a middle term, you got to look at that sign. It's a minus, so both of these have to be minuses. Okay. Anyhow, that's equal to 0. So I really have a x minus 3 squared equals 0. And when I apply a square root, it's going to give me an x minus 3 equals plus or minus 0, which is still going to be 0. You don't need to change anything with a plus or minus. So what's my final answer, guys? X equals what? Positive 3. Positive 3, not negative 3. Positive 3. Add 3 to both sides. 3 plus 0 is still 3. 3 minus 0 is still 3. All right, let's do one more. What now? What do I do now? Add 49. Okay, so let's go plus 49. Plus 49. Let's rewrite it. 4x squared minus 28x plus 49 equals 0. Then what? I need a factor so I could split it, so I could solve it. So what could I possibly do? What's the next step here? What do you guys think? Parentheses. We'd have to, so you're saying go through that multi-step process. The first step would be to multiply a times c. Damn, that's going to be horrible, right? Because 4 times 49 is huge. So there's a shortcut, special case. What's that special case? That we have a perfect square term in the front. And we also have a perfect square term in the back. So maybe I could square root them and plug them into my answer format. You guys remember that? So what's the square root of 4x squared? 2x. What's the square root of 49? 7. So 2x and 7 is my binomial. 2x and 7. Question is, what symbols should I put right here? 1 plus 1 negative? No, that would eliminate the middle term. So what do I want? Negative. Both of them negative. That's right. So let's put both of them negative. So from here, I could rewrite it as a binomial squared. 2x minus 7 squared. I mean, after all, it is written 2 times. This times itself. So you could rewrite it as that binomial squared, and it's equal to 0. So then we would apply a square root to both sides. Square root there, square root there. You'll end up with a 2x minus 7 equals a plus or minus 0. I know that the plus or minus on a 0 doesn't make a difference, but you might have a 3 out here sometime or a 5 out here sometime, and you will have to add the 5 and then subtract the 5 from the answer that you get here. So anyways, let's continue working. Whoops. Okay, so now we have space here. We're going to add 7. We're going to end up with 2x equals 7 plus or minus 0. And then finally, we need to divide by 2. Divide by 2. So what we have here, guys, is your x equaling 7 plus or minus 0 divided by 2. Now, like I said, in this case, adding or subtracting 0 doesn't make a difference. But sometimes you might have like a 3 right here. So 7 plus 3 would be 10, and then 10 divided by 2 would give you a final answer 5. Or you might have, and then you'd have to go back and do 7 minus 3. That would give you a 4, and then 4 divided by 2, the answer would be 2. But in this case, adding or subtracting 0 doesn't make a difference. So what's your final answer here? What's 7 plus 0? 7. What's 7 divided by 2? Exactly that. 7 divided by 2. And there is no plus or minus in front of your answer. The plus or minus was in front of the answer of the square root of 0. So when you add or subtract 0, you still get 7. That's why it's just one answer, 7 over 2. But like I said, sometimes you might have a 3 right here, and that would produce two different answers. That would produce 10 divided by 2, which would be 5, or it would produce 4 divided by 2, which would be 2. If you had a 3 right here. So it'd give you two different answers. But because it's 0, you only get the answer 7/2. That's it. So let's take a look at our homework, the second half of it. 8.9, down here it says solve each equation. So that's what you're going to be doing. You're going to be first setting it equal to 0, and then seeing if you could factor, not just by taking square roots, but any method, right? And you want to always start by factoring out the GCF. So jumping to number 20 right here, what is the GCF? What's the first thing I could pull out of there? The GCF right there would be the multiple of 2, right? What would be left on the inside? You'd have a 25b squared, you'd have a 10b, and you'd have a plus 1. And you still have the equal 0. Now, if you look at the inside right here, it's a quadratic trinomial in blue. And not only that, you have a perfect square term right there and a perfect square term right there. So you're going to square root both of them and plug them into your answer format. So the square root of 25b squared is 5b, and the square root of 1 is 1. So you have the binomial 5b and 1, 5b and 1. Now what symbols belong in here? Plus plus, right? Because you don't, if you put 1 plus 1 minus, it'll eliminate the middle term. But you want them both to be plus so you could get a positive middle term right there. So let's put a plus right there, plus right there. It is equal to 0 still. And we do have this outside 2. Now, if it weren't an equation, right? If it were not an equation, if I just told you factor, you would leave it exactly like this, right? Or you could also write it as like this. You could also write it like this: 2 parenthesis 5b plus 1 squared. You could write it like that. If I asked you to factor, you would either leave it like this or like this. But because it's an equation, because it's actually equal to 0, you need to solve it. So I would get rid of this multiplication of 2 that's out here by dividing by 2, dividing by 2. That would cancel it out, and you'd end up with your new equation. I'm going to write it up here. It's going to be 5b plus 1 in parentheses squared equals 0, because 0 divided by 2 is still 0. To get rid of the square, you're going to do the opposite, which is a square root. And you do end up with 5b plus 1 equals a plus or minus 0, because the square root of 0 is 0. Now again, the plus or minus in front of the 0 doesn't make a difference. So if you forgot to put it, in this case, you'd be fine. You'd still get the right answer. But I want you to remember, whenever you apply a square root, put a plus or minus, even if it doesn't make a difference, even if it's 0. Okay, because sometimes you'll actually get like a 9 in here, which means you're going to have to add and subtract 3 at the very end of it all. But anyway, plus or minus 0, let's continue working. We're going to subtract 1, subtract 1. Our new equation is 5b equals negative 1 plus or minus 0, which again doesn't make a difference. and then you're going to divide by 5, divide by 5. So your B value is, what's your answer? Negative 1/5. Since adding or subtracting 0 doesn't make a difference, you can just scratch it out, and here's your answer, negative 1/5. Negative 1/5. And that's about all we're doing, guys. So I believe you should have the skills to finish up the worksheet, okay? So go for it. Okay, so I want to do one more example, especially one that you won't end up with a 0, all right? So like number 24, you don't end up with a 0. I mean, you could do this many different ways. You could, if you wanted to, subtract 25 and subtract 25, but the better way would be to understand that there's a perfect square term here, a perfect square term there, so you could actually square root both of them and plug it into your answer format. The square root of x squared is x, and the square root of 36 is 6. And of course, the signs, you don't want them to be opposite because that would eliminate the middle term. So you want them both to be positive because that middle sign's positive. So we have a plus and a plus. We still have equals 25. So what I'm going to do is rewrite my x plus 6 binomial squared instead of multiplying it with itself, and then equals 25. Now why would I do that? Because I could now get rid of the square by applying a square root to both sides of the equation. So I will end up with x plus 6 equals, we need a plus or minus in front of our answer, and that'll be a 5. So my final step to get x by itself would be to get rid of this plus 6 by subtracting 6 and subtracting 6. So I'm going to rewrite my answer over here, x equals negative 6 plus or minus 5. Now, that's not my final answer because I could still do both situations. I could do negative 6 plus 5, but I could also do negative 6 minus 5. So negative 6 plus 5, the answer is negative 1, and negative 6 minus 5, the answer is negative 11. So we get two answers for that one problem. So it would be good to go back and test your answers. But can somebody check the back, the worksheet? Is the answer number 24 negative 1 and negative 11? Yeah. Yes? All right, so we're good.